Hi, I got a question about this problem, so I thought I would help some of you try to solve it. So this one reads, a 6-pack of 12-ounce soft drink sells for $2.62 and a 2-liter bottle of the same soft drink sells for $1.52. What is the cost in dollars per liter for each? So I'm going to solve this first one a couple of different ways. I'm going to start by setting up some of my own conversion factors and my own equalities. And this one reads a 6-pack of, let's see here, this one reads a 6-pack, I'll change the color, of 12-ounce soft drinks. So that is going to be 6 times 12 is 72. So we're going to put 6 cans. I'm guessing it's cans. So let's put 6 cans here. And it tells you the volume of each can. So one can is 12 ounces, and so I put cans on the bottom so it can cancel. And let's see, now we're going to convert this to liters because we have to. It wants us to know what is the cost. Our end game is to get cost in. We want to get dollars per liter. We already have dollars. The dollars is $2.62 for this first one, and we just need to get the liters. So our job is to convert now what is going to be ounces into liters. Because a couple ways to do that. I'll do it the sort of the good chemist way first. So we'll start by saying there are 8 ounces in 1 cup, and these are values that are in your book, or you know them or can look them up. So sorry about my handwriting. 8 ounces is 1 cup, and you can either say there's 2 cups and 1 pint, 2 pints and 1 quart, or you can say there are 4 cups in 1 quart. There are, there are 4 quarts in 1 gallon, and then there are 1 gallon is 3.785 liters, and that's in your book too. So what we did was we started here, we said cans on the numerator, and so can has to be on the denominator, so they cancel out. Ounces cancels ounces, cups cancels cups, quarts cancels quarts, gallons cancels gallons. We're left with liters. That's what we're looking for. How do I know what to set up and how to do this? It's mostly practice, but as long as the numerator and the denominator equal one another, then you're good. For example, 1 can is equal to 12 ounces. So if that's true, if those two things are equal, then any ratio of those equals 1. You're multiplying the initial number by 1. So it's still, you can do that. So let's do this math here. I'm going to erase this part. So we'll go back and I'll change the color slightly. No, and I will bring in the calculator here so I can kind of follow along with what we're doing here. Hopefully you can see what I'm typing. So I have the big keyboard out. And the calculator, this is the TI-84 plus CE. I'm using this as my model here. So I'm going to do all the stuff in the numerator divided by all the stuff in the denominator. So I'm going to put a left parenthesis, and I'm going to go 6 times, let me move this calculator, this thing off screen. I'll put the calculator up here so you can see what I'm typing. 6 times 12 times 3.785. I'm leaving the ones off. And then I'm going to divide it by 8 times 4 times 4. So 8 times 4 times 4. So, and I didn't really have to, here, I'll put this in, this is going to make a mistake. I did something wrong here. I have to go back a little here. I should have put this in parentheses. Divided by 8 times 4 times 4. And that comes from here. That's what this is. It's 6 times 12 times 3.785 divided by 8 times 4 times 4. And that should give me the number of liters that I have. So I'm going to press enter here, and I get 2.129 liters. I'm going to go ahead and record that value here. It's going to be 2.129. Oops, sorry. I got to get back to the pencil here. I'm going to put 2.129. I just have to carry more significant figures than I've been given in any of my givens here, which is 3. you don't count definitions towards significant figures, so none of these count towards the number of significant figures that I'm carrying. So another thing we can do is to say, okay, we're looking at 6 times 12 or 72. We're looking at 72 ounces, and the question is, how many liters is that? That's what we just calculated. So what we'll do is we'll go to a handy browser here, and so I'm just going to go ahead and type in here. I'm going to type 72 ounces in liters in L and hit enter. And it gives me 2.129, the very same thing that I got right here. So you can see that. So I think if you have a preferred search engine, I'm pretty sure they all do it. We'll say 72 ounces in liters, and yep, same thing here in Bing, and we'll try Yahoo, see if Yahoo comes up with anything different. There's a not very handsome fella. 72 ounces in liters, and who failed? Nobody failed us, so every place did it just fine. I think, Google is probably your favorite, doesn't matter. And then we take 2.62 divided by 2.129, and so then I just have to find where I put the calculator. I say I'm going to take the calculator and do 2.62, so I go 2.62 divided by, and then I can just sort of up arrow up over to this answer here since I already have it. Hit enter, and I get this copies this down to here. I hit enter again, and it gives me the answer of 1.2305. So it's going to be the answer here is 1 point equals 1.2305 right now, but then we have the matter of significant figures to it. And this problem has, we have 1.2305, and I'll erase this and write this over again so it's a little easier to read, is the answer that shows up in our calculator. So I'll switch this over to the pen again, and we're going to put 1.2305, and the question is, how many significant figures do we want to retain? And I think our calculator came up with even more. It said 1.2305, 885, blah 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 blah. So it's a lot of numbers. So what's the appropriate number to write? So up here we have a few numbers. We have a 6-pack, and that's a count. So we have a 6-pack. Those are count numbers, and you don't apply significant figures to count numbers or defined things that are accepted to be that value that aren't measured this one particular time. And part of this is art and part of this is science, because you have to decide what is defined and what is measured. But in WebAssign, a clear indication of it is that everything that is in red text in WebAssign for your homework is something that contributes towards the significant figures. So the 12 ounces we're saying is defined as 12 ounces in a soft drink. It's of infinite accuracy, which is of course false, but you have to know how WebAssign works to understand this. And we're saying a 2.0 liter bottle, which normally you would say, hey, that's only 2 significant figures. But we're also saying that's defined, and I only know that because it's in black here. If it were in red, I would say, okay, we only get 2 significant figures. So the one thing that's measured and counts towards insignificance here in this particular problem is this dollar sign here, this amount, which is 2.62. So we're limited to 3 significant figures. So we'll report our answer as 1.23 or $1, and the answer would be it's $1.23 per liter is the answer you want to put. And the other problem I'm going to leave to you because it's much simpler, because it is going to be the same soft drink. A 2-liter bottle is, and we talked about the significant figures a moment ago, is $1.52. So you have you just have $1.52 divided by 2.0. And again, in this particular case, we would just leave that at 3 significant figures for the answer, which will be, we can just do that real quick here. It would just be 152 divided by 2.0, and so we would say $1.52 divided by 2.0, enter, and you get 76 cents. I'd put 0.760 to maintain the 3 significant figures. And I hope this helps. Have fun.